Hey guys, here I have a real quick concept, the way the universe works. The fact is, the universe is not flat. It's a cone-shaped cylinder in this way direction, but it is cone-shaped and narrows at the beginning of the Big Bang, and it becomes larger as you go. And the way I can prove that is observation, power observation. Normally, this is Earth, and this is a circular in this form. Uh, Pretty much what tells you that's the edge of the universe. The edge of the universe is basically like a cone shape, getting smaller and smaller at the beginning of the Big Bang, and the circles getting larger and larger and larger. That's the edge of the universe. But anyway, this is Earth, and if Earth was just a flat universe, which is not, but let's pretend it was flat, then all the planets you will see on the horizon. You'll see 360 degrees around you, but in a flat horizon. So you will see stars all this on this curvature right here. You will see that because it'll be flat on the horizon. So you will see all this star right here, maybe just a little bit higher, and that would be it. But that's not true, because in reality, at nighttime we can see stars around us, 360 degrees on the horizon. But not only that, we see stars above us, all the way around us. Remember, if you walk in the desert or anywhere that's flat surface, you could see as far as the eye can see, and that's it. You will only see a flat surface. You wouldn't be able to see the sky, right? In reality, if you were looking for dirt, ground, and gravel, whatever, you will see it in a flat surface. You will not see that out in the sky. All right, so the sky is a different horizon. It's basically a vertical, whatever we want to call it, but our horizon will be just the ground itself. So in an Earth, the horizon will be the stars around, just a little higher here, and over here, and anything underneath, you'll be able to see it. That's our horizon right there. But at nighttime, we see more than that. Not only do we see the horizon, we see the sky on top, which is all the vertical horizon, vertical and horizon. So you'll see the horizon and you see the vertical above us. So it'd be 360 horizon plus the 360 vertical all the way around. So basically, we get four-dimensional view of the sky. You get the horizon, you get the vertical, 360 degree all the way around. So that's why you can see the stars at nighttime all the way around the visible at nighttime, and you can see the stars all the way around. There's no empty spots. There's no black shades. And, to our eye, everything in the sky is covered with stars, and that's a fact. And that proves that the horizon and the vertical 360 degree is basically proof that the universe is in a cylinder, circular way, more or less. But it's like a cone-shaped universe. This is the Big Bang, and it started small and it's increasing. The tubular cone-shaped circular, it's increasing, and that's because more matter is coming in, and that's inflating more the Big Bang for the expansion. Hold on, let me explain real quick this terminology here. We have the beginning of the Big Bang. We have three planets here: one planet, second planet, and third planet. We have a cone-shaped, triangular-shaped cone. So at the starting point, you get three planets, same. Even though it looks like one's higher than the other one, basically it's the same plane. Remember that, because it's a circular, or the skin itself of time and space is round. So these are the same level distance from the black hole. One looks at the bottom, but it's not really the bottom. It's the same level, same plane field, same distance from the black hole, or in this case, the Big Bang. Same distance from the entry of the Big Bang. So starting point, you got three beginning galaxies, or starting to form galaxies, and each one's going to take a path in the same direction. So if you do that, let me show you. Let's pretend that this, over time, this one will move over here. This one will move over here. And this one will move over here. As you can see, the distance is increasing as time goes by. As they move forward in time, start pointing here, move in time, it starts increasing the space between planets and galaxies. Basically, between galaxies, the space between starts increasing. Same here. As beginning Big Bang, galaxies are separating, expanding, separating. Basically, what I believe is the universe is like a balloon. It's inflating. More material is coming in. So as it inflates, the planet is traveling in these surface of these time and space is actually expanding, as you can see. So that's the way it is. That's my concept of the way it is, and basically it also spins direction. And if you know anything about inertia, inertia creates gravity. Point and simply. So our invisible force of gravity is basically inertia. That means that the cone itself is spinning in one direction, and while it spins, all the planets are being pushed to the edge of the skin of the cone, and that would get attached to the surface. So all around the surface, there's stars, universe, galaxies, planets, whatever you want to call it. Everything's on the skin, but nothing in the middle. All the stars are on the side. I have another video. I just did it before this one. This one's just a short to show you guys the concept that the planets, the galaxies are expanding as time goes by, and basically that the universe is a cone shape and it's not flat. So even the stars, like this one, if Hubble telescopes, when they take the view of different stars, galaxies, proves that the universe is a cone and not flat. Because in the galaxies, when Hubble telescopes, all the pictures of Hubble telescopes and they're taken, these are galaxies. See how some have vertical, some are horizontal, some are at an angle, a different angle. That's because if everything was horizontal, it would be simply like this. In a distance, you will see this way. Everything will be flat. But since it's not, in a Hubble telescope, everything is vertical, horizontal, angle, vertical, horizontal, angle, whatever, different angles. That suggests that the skin or the fabric of time and space is curved in a cylinder motion in a cone shape. So everything, the galaxies will be in a different angle. Some will be vertical, some will be horizontal, some will be a 45-degree, 35-degree angle, the universe, the galaxies themselves. So that's why when you take a photograph from Hubble, all these universe, even though they're far away, why they're so not flat, but in different angles? That's because they're following the same structure of the cone shape. That's why you see the galaxies in Hubble pictures in a different angle themselves, because they're in position in a different part of it might be the same distance, but a different part of the curvature that allows them to be different. Like this, for example, this universe, this galaxy here will be this way, right? And then this galaxy here will be this way. See what I'm trying to say? So you got the view will be to be horizontal and vertical, or a little angle. So that's what I'm trying to say. And here will be a different angle. So depending on where the galaxies are, that tells you what angle the galaxies themselves will be, depending on where they're at in the circular cone shape area of the universe they are. So if they're over here, let's put it this way here. So this will be almost vertical. So what I'm trying to say is, because the proof is the Hubble telescope proves that my theory is right, that the galaxies are positioned around in a circular cone shape. Depending on the photographs, that shows you some are a different angle, some are 45, some are vertical, some are horizontal, some 90 degrees, whatever. The angle depending proves that depending where the galaxies are in a 360 circle of the cone itself. So that's my proof. It's basically on power of observation. There you go, folks.